So, very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the participant branches along with your class 6th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter, work, power and energy. And today we are entering into the session number 2. So this chapter, that is chapter number 4, we started in the last session. So today is the second session. So we'll continue where we left in the last class. But before that, let us recall what we learned in the last class. So as you all know, we learn about the first very important quantity, that is about work. So in last class, we discussed about complete details about the work, right? So what is work? Work done, right? Then what are the types of work done? That is positive work, negative work and zero work, right? So we have derived the mathematical formula also for work, which is given by W is equal to F into S, or W is equal to F into S cos theta whenever a force makes an angle of theta with the direction of displacement. So these total things we learned. So generally, when you said work is done, when body displaces or when body changes the position along the direction of force, then we can say that there is a work done. There is no displacement. Suppose displacement is 0, then work done is also 0. Even though you are applying any amount of force, if body not displaces or body not changes its position, then you can say work done is 0. There are some cases where the force applied and the direction of displacements are opposite. Such work done is called negative work done. If body displaces along the direction of force, the force will be either pull or push. Then we can call it as positive work done. Right? So all these topics we'll discuss in the last class. So we'll continue same with the new part of the chapter, that is our next part, that is energy. So these are the types of works done you have seen. So work is measured in joule or erg. So work done, positive work done, negative work done, all we have seen. Okay. Now second part is, after all, is all you have to complete based on the work done only. The second one is energy. So today we are going to discuss about what is energy. Okay. What are the kinds of energies or types of energies? And by end we'll discuss about even power also. These are the 3 important physical quantities of the chapter. Now we'll see energy. Everyday language, we use the word energy in many different ways. Correct or not? It may be electrical energy, magnetic energy, muscular energy, any energy. But commonly we discuss in our day-to-day life. The scientific way of thinking after energy, it is the property of something makes it able to exert the force and do work. So energy is the one which help us to do the work. Correct or not? Further, we'll go for the gym, we'll build the body building. Everything is only to produce the energy. Produce the energy. The capacity, the ability to do the work. Right? So how much capacity you have to do how much weight you can lift, how many kilometers you can run, how many push-ups you can do. All this depends on your energy only. because that is your capacity to do energy, do work. So the energy is the body defined as the capacity for doing work. Right? Very important point you can note on this. The energy of a body is defined as the capacity for doing work, or ability to do the work, or your tendency to do the work, right? So since energy of the body is there, right? So since energy of the body is the total quantity of work done, it is a scalar quantity. So energy is nothing but work done only. But how much you can do is that energy. So dimension formula you have seen, you are not much known. So units, joule or erg, joule in SI system, erg in, that is both energy and work are having the same units, because energy also a capacity of doing work. Right? So there are some conversions are there. You can see how these units are converted. Right? So units of the work is joule and practical unit of electron volts. Practically also there are some units, electron volts. Kilowatt hour is also one of the unit. I will explain that. Where 1 joule is equal to 10 power 7 erg. So there are some values, constant values to be remembered. 1 calorie is equal to 4.18 joule. 1 kilowatt hour is equal to 3.6 into 10 power 5. Very important that. How do you come? I'll explain you. Right. So 1 electron volt, 1 kilowatt hour, 3.6 into 10 power 6 joule. 1 calorie is equal to 4.18 joule. These are the conversions. Right. So commercial unit of energy, commercial. Generally we'll use electricity, electrical energy. So we cannot measure that in joules or ergs because that is a big amount. In case of big energies or commercial energies, we'll measure in the kilowatt hour. 1 kilowatt hour is equal to, you can call it as 1 unit. In bill, if you see electricity bill will come, you can see how many units you are burned. So each unit cost is some 8 rupees. So then how they give the bill? Number of kilowatt hours, that is number of units into 8 rupees. We'll get the bill. So electricity bill is measured or comes under commercial unit of energy. So where 1 kilowatt hour is equal to 1 unit as per the electricity department. How many units you utilize, that much bill you will get for a month. So what is kilowatt hour? So 1 kilowatt hour, if you see, 1 kilowatt hour. I told it as a 1 unit. Kilo means 1000. Right? Watt as it is will keep. Hour. Hour means we can convert into seconds because time always measured in second. Hour is nothing but 60 minutes, 60 seconds. So 1000 into 60 into 60, 3600. So now hour we convert into second here. So watt as it is. So watt second. Watt already there. Watt and second also there. Watt second. So 1000 to 3600. 36 into 10 power 5. Watt second. Watt second is nothing but joule. 36 into 10 power 5, or you can write 3.6 into 10 power 6 joule. How watt second is joule will come across next when you discuss about the power. Right? That is the commercial unit or largest unit of the electricity. Okay? Commercial unit of energy is 1 kilowatt hour. Generally, energy is nothing but capacity or ability or tendency to do the work. How much capacity you have to do the work is called energy. So energy is nothing but work only. So it is also measured in either joule or erg. Measured in joule or erg only. Okay, measured in joule or erg. And commercially it is measured in kilowatt hour. See, if you go and see at home, you can find the electric meter, where you can see the readings. You observe that meter, there it is written as kWh. Whatever the meter reading is there, he is measuring kWh only. When they are taking the bill also, they record that to this and get the bill immediately. So 1 kilowatt hour is nothing but 1 unit. How many kilowatt hours you consumed? Based on that, your electricity bill will come. That is the commercial unit of the electric current. Right? Then, now come to the kinds of energies, where there are various types of energies will come across in our day-to-day life. Okay, number one, mechanical energy. Mechanical energy means the energy applied by you. The sum of the energies of kinetic energy and potential energy together called mechanical energy. So we'll tell what is potential kinetic. So mechanical energy is equal to kinetic energy plus potential energy. That is the energy produced by body in motion plus in position also. So the produced by body in motion is called kinetic energy. At same position is called potential energy. So both together is called mechanical energy. Whether body may be moving or body may be at same position, they produce energy. Such an energy is called mechanical energy. Right? In that again there is a classification. Potential energy. Energy processed by a body virtue of its position. For example, you see, overhead tank is there, water tank. Water tank is not moving. It is there only, but it has energy, and with that energy, it is send the water to our taps. Correct? So aeroplane, which is at a height from the ground. When aeroplane is hanging in the air also, it has energy. Or when aeroplane is moving, that is different energy. Okay. So being at same position, the body possesses energy. For example, take catapult or arrow. When you catapult is stretched, the energy produced by catapult is potential energy. When that is released, it becomes kinetic energy. Right? So that is. So water stored in a tank, compressed spring. When you compress the spring like this, the energy possessed is potential. Even though it is not moving, it is having the energy. Right? The energy possessed by a body, virtue of its position, is called potential energy. So formula also there for potential energy, very important, mgh. Potential energy is nothing but M. For example, see, it is a ground. Right? You place the body here, one block of wood. You raise that one up to here. Right? Raised. So then potential energy is given by, potential energy is nothing but work done only. Work done, that is force into displacement. So what is the displacement here? H. So what is the force? Mass into acceleration into S. So mass of the block is mass only. A is nothing but G, because acceleration due to gravity. S is nothing but H. So potential energy is given by mgh. The work done in lifting the body from the ground, which is at a position, is a potential energy. It is mathematically given by mgh. M is the mass, G is the acceleration due to gravity, H is the height. At what height it is there. Right? That's all same gravitational potential energy. Potential energy by the earth, that is earth. The force of gravity between an object and the earth pulls the body towards its center. Right? Of the planet. If an object is positioned above the surface of the earth, it possesses stored energy, which is called gravitational potential energy. So that is also same mgh formula. It is also called as gravitational potential, because potential energy due to gravitational force. Clear? So mechanical energy is nothing but potential energy and kinetic energy, whereas potential energy is nothing but energy possessed by a body virtue of its position. Next, kinetic energy. Energy possessed by a body virtue of its motion. Every moving body possesses the kinetic energy. Either flying bird, moving car, riding bicycle. Every body which is in motion will possess kinetic energy. Right? Moving body possesses kinetic energy, which is mathematically given by the formula kinetic energy is equal to half mv square, 1 by 2 mv square. Right? Whereas potential energy is given by mgh. Formulas are very important, these two. The energy possible by which its motion is kinetic energy, which its position is potential energy. Right? So examples given. Flowing water. Right? Moving vehicle. Moving air. Wind. Wind energy only. The hammer possesses kinetic energy. Use it to drive the nails. When you are hitting the nail into the wall. A bullet fired from the gun is also a kinetic energy. Right? So from that they get the derivation as 1 by 2 mv square is the mathematical formula of the kinetic energy. Mechanical energy, potential energy, kinetic energy, of course gravitational potential energy. Potential energy due to gravitational pull. Clear? So this is about the simple energy. Of course there is a continuation is there. When law is there, then we'll enter into the power. But before that, let me check with the video. One video I'll show you about the energy, types of energies, right? You see the video, then we'll move to the law of conservation of energy.
Earthpen. Hello learners, this is Earthpen. Today, we are going to talk about another fun topic in physics. It is all about the types of energy. Energy can be categorized into two broad topics, the kinetic energy and the potential energy. These two are the basic forms of energy, and we know that kinetic energy is the energy of moving objects, while potential energy is energy that is stored. But aside from these two energies, there are also other types of energy. This includes thermal energy, radiant energy, light energy, chemical energy, nuclear energy, electrical energy, gravitational energy, and mechanical energy.
Thermal energy is nothing but heat energy. Radiant energy produced by sunlight, solar. Light energy you are seeing. Chemical energy. Nuclear energy, where the nuclear bombs and everything prepared. Electrical energy. Gravitational energy. Energy of the earth. Of course, mechanical energy. All these are the various types of energies which we'll use in our day-to-day life.
Let us discuss them one by one.
See, clearly they explain.
The first type of energy that we're going to discuss is the thermal energy. Thermal energy, or also called as heat energy, is produced when there is a rise in temperature that causes atoms and molecules to move faster and collide with each other. But how is thermal energy produced? Thermal energy is the energy that comes from the heated up substance, which means that the hotter the substance, the more its particles move, and the higher its thermal energy. To better understand this, let us have an example. Say you have a hot pot. You forgot that the pot is hot, so you grab it with your hand. Now your hand is burnt because of the hot pot. The thermal energy from the hot pot is being transferred to your hand. That is why you felt the burn in your hands. So, better be careful when dealing with hot things. The next type of energy that we're going to discuss is the radiant energy. So what is radiant energy? Radiant energy is a form of electromagnetic energy. This type of energy can take form of visible waves, which is what we call light energy. But we will be talking about light energy later. The sun produces a lot of radiant energy, which is transmitted to Earth as light. Radiant energy that is transmitted by the electromagnetic waves can come in different forms. Some examples of radiant energy are from the sunshine, X-rays, and radiant heating systems. I have mentioned light energy and radiant energy. But what is light energy? Light energy is a form of electromagnetic radiation of a wavelength, which can be seen by the human eye. It is a type of kinetic energy. In an electromagnetic spectrum, we can see that light has the wavelength visible to our eyes. Light energy is formed through the movement of photons. Photons are like tiny pockets of energy. So when an object's atoms heat up, photons are produced from the movement of atoms. Also note that the hotter the object, the more photons are produced, and that is how light energy is formed. If you're asking how light energy is used, well, basically, light energy is used to help us see. The light can either come naturally with the use of the sun or fire, but it can also be from man-made objects like candles or light bulbs. Light energy is also used by plants during photosynthesis. Plants capture the light energy from the sun and use it to produce their food.
The energy we are using for various purposes.
Next, we have the chemical energy. Chemical energy is stored in the bonds that connect atoms with other atoms and molecules with other molecules. Because chemical energy is stored, it is a form of potential energy. So what does that mean? It means that when a chemical reaction takes place, the stored chemical energy is released. Chemical energy is the most widely used type of energy in the world. Most humans don't know that they are already using chemical energy. But how is it used? Chemical energy can be found in your food, in a burning wood, and even in photosynthesis. Chemical energy is produced in the food that we eat, and that energy keeps us warm, helps us move, and allows us to grow. Stored chemical energy can also be found in coal, biomass, and chemical batteries. Next type of energy is the nuclear energy. Nuclear energy comes from the nucleus of atoms. How is nuclear energy released? It is released by nuclear fusion or nuclear fission. Nuclear fusion is when the nuclei are fused together, while nuclear fission is when the nuclei are split apart. Nuclear energy is a non-renewable energy source that comes from the nucleus of atoms. Nuclear plants use nuclear fission of a radioactive element called uranium to generate electricity. So how does it work? The nucleus of our uranium atom is hit by a neutron. It causes the uranium atom to split into two atoms, and at the same time, the energy is released in the form of heat and radiation. And as a result, more neutrons are released, which means that the process repeats itself. Or in simpler terms, there is a chain reaction during the process. Did you know that nuclear power plants must shut down every 18 to 24 months in order to dispose the used uranium fuel? This is because the uranium fuel becomes a radioactive waste.
Very powerful energy.
Moving on to the next type of energy, we have the electrical energy. Electrical energy is caused by the movement of electrical charges called electrons. The faster the charges move, the more electrical energy they carry. Since the charges that cause the energy are moving, then we can say that electrical energy is a form of kinetic energy. So what are the examples of electrical energy? The first example that we will tackle is during a thunderstorm. When there is a thunderstorm, we can see lightning, right? Did you know that lightning is a form of electrical energy? That's right. Lightning is a form of electrical energy since during a thunderstorm, two electrically charged regions in the atmosphere temporarily equalizes themselves, causing the instantaneous release of energy. In other words, electricity in the atmosphere is being discharged. Another example would be electric eels. Electric eels generate electrical energy, which they use to defend against predators and to stun their prey. And now we have gravitational energy. Gravitational energy is the kind of energy associated by no other than gravity. It is the potential energy stored by an object because of its higher position compared to a lower position. What do you think causes gravitational energy? Gravitational energy occurs and increases as an object or a system moves away further from the center of the Earth. Gravitational energy is dependent on the masses of two bodies, and their distance apart. An example of when you can experience gravitational energy is when you are riding a roller coaster. When you are riding a roller coaster, you experience microgravity, which means that you are moving in the same speed as the vehicle you are riding in. As I have said, when something is in a higher position, its gravitational energy is high. So when we place a book on the top shelf, it has a higher gravitational potential energy than the book on the bottom shelf because it has farther to fall. The last type of energy that we are going to discuss is the mechanical energy. The type of energy that you use when working or the energy acquired by the objects upon which work is done is known as mechanical energy. Mechanical energy is the type of energy that an object acquired due to its motion or position. Note that mechanical energy can be either kinetic energy or potential energy.
We discuss.
An example of a mechanical energy is a moving car. The car possesses a mechanical energy due to its motion, and since the car is in motion, the mechanical energy in this example is a kinetic energy. Another example would be lifting a ball over your head. The lifted ball possesses a mechanical energy due to its vertical position above the ground. And since the ball is stationary, then it is in the form of potential energy. Before we end, let us first summarize everything. Today, you learned about the 8 types of energy, namely thermal energy, radiant energy, light energy, chemical energy, nuclear energy, electrical energy, gravitational energy, and mechanical energy.
Right. So one more is there, we'll see before closing the session. One more just video.
Spiky looks tired. Let's give him something to eat. He seems to be fresh and active now. Do you know why Spiky was feeling dull before he ate the chocolate? This is because he had low energy. We need energy to work, and this energy comes from the food we eat. Energy is the ability of a body to work. There are various forms of energy. Some forms are heat energy, light energy, chemical energy, nuclear energy, electrical energy, sound energy, wind energy, kinetic energy, potential energy, and mechanical energy.
You can note down all these things. Different forms of energies which will come across in our day-to-day life. Daily, we'll come across one or other in our day-to-day life. We'll use heat energy, we'll use light energy, we'll use chemical energy. Of course, nuclear energy we won't use. Electrical energy, sound energy, wind energy, kinetic, potential, mechanical, everything. All forms of energies we'll use some or other day in our life. Very important. Note down all the names. Types of energies or form of energies. Various forms of energies. Energy is nothing but the capacity to do the work. And various forms are here. Heat, light, chemical, nuclear, electrical, sound, wind, kinetic, potential, and mechanical. Right.
Energy. Let's identify different forms of energy around us. A family is going on a picnic. It's a sunny day. The sun provides us with 2 different forms of energy. Can you guess what these are?
Heat, light.
Heat and light energy. Energy from the sun is called solar energy. Plants use solar energy for photosynthesis. The family is going to the park in a car. How does a car move?
Chemical and petrol.
It moves because of the chemical energy stored in fuel. In the park, everyone set up for the picnic while children are playing. Energy is also used to help things move. This energy is called kinetic energy. Now they're sitting at the table. Even sitting down requires energy. The energy of a body when it is at rest is known as potential energy. Now they're listening to some cool music on the radio. It runs on electrical energy from the battery. What kind of energy is the radio producing? sound energy. Sound energy is produced when an object vibrates and disturbs the air particles near it. Thus, the energy of a vibrating body spreads out in the form of waves. When these waves enter our ear, we can hear the sound. The kids are playing on the swings. How does the swing move?
Mechanical.
The swing moves using mechanical energy. Mechanical energy is the energy possessed by a body due to both motion and position.
This kinetic and potential together called mechanical.
Uncle is making a fire in the grill to cook food. What kind of energy is Uncle
Heat.
using to cook the food? He's using fire, which gives us heat energy. Heat cooks our food. It is produced when the particles of a substance start to move faster and faster and start to collide with each other. Look, a kid is flying a kite. How is the kite held up in the sky?
Wind.
By wind
Wind
energy. Moving air is called wind. What kind of energy can we find in other things or people that were not doing anything, such as grandma sitting on her wheelchair and the trees in the park or uncle's grill? Do you think they have no energy because they were not moving? Do you remember what kind of energy a body has based on its position?
Potential energy.
Potential energy is stored in a body which is at rest. Let's summarize.
Right.
Energy is the ability of a body to work.
So one
There are
of-
various
Can you
forms of
explain?
energy. Some of them are heat energy, light energy, electrical energy, chemical energy, sound energy, mechanical energy, potential energy, kinetic energy, and nuclear energy.
Right. So there are various forms of energies which will come across during our day-to-day life. So that is about energy. So when you meet in the next class, we'll discuss about what is law of conservation of energy. So for example, you have filled the petrol in 1 liter. When you travel for 30, 40 kilometers, petrol is over. It doesn't mean that your petrol is wasted. What is happening here? Their heat energy is converting into mechanical and making the vehicle to move. That is, energy can be converted from one form to another. But there is no wastage of energy. Neither you can create the energy nor destroy the energy. That is called law of conservation of energy. There are hundreds of examples. When you electricity you are using, so that electric current is converted into mechanical when fan is moving. It is converted to light when the bulb glows. It converted into heat when the air conditioned or geyser or others are. They are converting one energy into another energy. But there is no loss of energy. So energy neither be created nor destroyed. It may change from one form to another form. That's all. That statement is called law of conservation of energy. So finally in the next class, we'll discuss about the last part of this chapter. That is about power. What is power? What are the units of power? Simple. No more explanation. One class you can complete before starting the chapter number 5. That is heat. Okay. So work is done. We study about the energy also and forms of energies, types of energies, everything we have seen overall. So next class when we meet, we'll discuss about the law of conservation of energy followed by about the last word power, with which we have closed the chapter. Right? So that's all for today. Thank you all the students. Have a wonderful day. Thank you.